Okay, so in this session, we're going to do some problems covering benefit cost ratios, incremental benefit cost ratios, and also some previous methods has been used for comparing multiple mutually exclusive projects, and maybe 3 to 4, depends on time. We're going to do 2 hours. Okay, let's get started. So first, we're going to see the problem on the left side, and I can let you spend like 2 to 3 minutes to read about this problem. 1 to 2 maybe, that's enough. Let me resume. So for this problem, we're going to use the benefit cost ratio analysis to do this, and especially the incremental benefit cost ratio. So at the very first step, we are going to rearrange, like reordering these projects. So as we have seen in the textbook or in the lecture videos and in my video too. So the first thing is reordering. So from the least costly, from the initial, here we're just looking at the initial investment. So the ordering will be from the least to the most expensive. So A, C, and B, right? So let me write down what is for that. C is minus 20. 200,000. B is 25,000. And I drop down all these numbers. A little bit tedious just repeating these numbers, but it's good for explanation. Please bear with me. It's just spending some time writing these, just copying these numbers from the left hand side, and make us easier to read. How are we gonna proceed? Okay. No, I already copied it the wrong way. C is 8. And that's 120,000 and so when doing with a benefit cost ratio analysis, especially for the incremental one, comparing multiple projects, you're always gonna reordering those projects based on their cost. Here is for example is an initial investment from the least costly to the most costly. So like this increasing order, and then we can check on the first. Check this first. Check the least costly project first. So what do we check? It's based just benefit cost ratio. Check if that's greater than 1 or not. If that's greater than 1, then we can set this guy as the baseline, and then we can continue to check the next to be compared with that. If it's not, so yes, that would be the baseline. No, then we move to the next expensive one, or next. Good. Okay, so now we're going to calculate the benefit cost ratio of project A. So as long as we know this order, we can. So I'm going to move down so you can check the numbers on the left side. So here for A, we first calculate the, as here I'm gonna use the present worth to calculate the benefit cost ratio. So for the benefit part, benefit of A, just read a shortcut. So so what do we recognize here? This A 80,000, 70,000. So there's a very obvious pattern. So this this is the, so you may recall this is the uniform gradient series. But remember, for a uniform gradient series, what do we need for the first year? That's basically 0. So we need a 0 for the first year. And starting from the second year, that raised by g, and third year, that's 2g, and so on. But here it's, and here it's starting with 80,000. So that's not a 0, and we need to do some manipulation on this one. So a very straightforward one would be, we have set this as 2 parts. So it's basically the annuity plus the uniform gradient. So we can separate these 2 parts. The first part will be the annuity part for the first year until all the way to the 4th year. So for the first year, that would be 80,000. So because we are setting up the uniform gradient, the first year of the uniform gradient should be 0. So that's 80,000 plus 0. And for the second year, that's 80,000 minus 10,000. So you're getting 70,000 for the second year. And that should be applied to 30 and the 4th year, following the same pattern. So we're getting these guys. So that's exactly the annuity plus the uniform gradient. And then we can calculate the benefit of A. The present worth, I just write present worth of benefit of A. Just see that, use that. And that will be the annuity. So we want to calculate so we want to find the present worth given the annuity. And that's for 10% interest rate and 4 years. So the annuity here is 80,000. And then we have the gradient part, uniform gradient part. And that would be, since an incremental value of g, so that's just 10,000. And then given that uniform gradient, we want to find the present worth, given 10% interest rate and 4 years. And so that's for the benefit part, for present worth of A. And now check the cost part, still doing the present worth. But that for A, that's very straightforward, since this year 0 and cost is 160,000. So for the cost part, the present worth of A is that's just 160,000. Okay, so then we can just plug in these numbers and doing the division here. And then we will get this number. You can check yourself offline if you're interested. So this guy will be just 1.31. And that's definitely greater than 1. So we will keep this A as the baseline. Okay, so let me pause here. So do you have any questions until this step? If you don't want to speak up, you can just type in the chat, and I can check as well. Since we have few people, so you can also speak up.
I think I'm okay.
You okay? Okay, good. That's good. So let me continue the second step. So then, because we rearrange those alternative projects, so the next step will be the next least costly projects to be compared with A. So that would be C. So that's step 2. just take more notation there. So step 2, so we want to compare C with A doing the incremental benefit cost ratio analysis. So we first want to know the delta benefit in present worth, and then C minus A. So project C compared with project A, and the benefit part, it's so we have actually done that. So but let me first write out that. So from the table, I just do direct translation here. So for A and C, the benefit deduction. So maybe I just write the other order. That's easier for the notation. So first year, that for C is 80,000, A is 80,000 as well. And because C is all 80,000, I don't write anymore. That's for A, that's decreasing by 10,000 each year. So we take the difference, use A subtract by A, and then we get 0, 10,000, 20,000, and 30,000, right? So that's obviously the uniform gradient starting with year 1, that's 0, and all the year down is incremental by 10,000. So that's why we can use find the formula, find the present worth given the uniform gradient. So 10% for years, and we have the incremental. The uniform gradient would be 10,000 per year, and then we are down for the delta benefit part, and for this delta C and delta C minus A. So the cost of project C minus cost of project A, that would just be 200,000 minus 160,000. So that would just be 40,000. Then we can just plug in those numbers. Yeah, I think that's clear. So just plug in those two numbers, and then we will get this ratio is 1.09, which is greater than 1. So from this, we can conclude that the C is better than A. So we can drop, and then we can drop A and set C as the new baseline. Okay, and do you have any questions until this step? Are you all good? Since I think it's similar to the previous one, actually we don't need any other manipulations, so it's very straightforward. So let's move on. Now we still have one project left, and that's B. We have now have alternative B to be compared with A. C, sorry, that's C, compare with C, since we have already dropped A. So now we want to calculate the incremental benefit cost ratio compare between B and C. So that's exactly the same idea. So we drop down these numbers for the benefit part, because the benefit part is more complex, starting from 1, 2, 3, 4. B is for the first year 120,000 and 100,000, 80,000, 60,000, and for C that's all the same, 80,000, 80,000, and all the way. So the difference between B and C would be, so we just use the benefit of B minus benefit of C each year. That'd be 40,000 for the first year, 20,000 second, and it's 0 minus 20,000 for the fourth year. So here it's same idea. We see that's the pattern that decreased by 20,000 as a fixed amount. So we will definitely use the uniform gradient formula, but that requires the first year to be 0. So we're gonna apply the same trick. So treat as two parts. So we have the annuity part and the gradient part for the 4 years. First year 40,000 plus the gradient, that's 0, and that should be all 40,000 to the end, and this G would be minus 20,000 minus 40,000 and minus 60,000. So then we can calculate this benefit part. So that's B compared to C. So the benefit part will be the annuity plus the gradient part. So the annuity part would be we want to find the present worth and give an annuity, which is 40,000 and 10% for 4 years. And the gradient part, since it's decreasing and it's minus, so we minus 20,000 and make sure the first year is 0. Then we want to find the present given the gradient, 10% for 4 years. Okay, then we are done for the incremental benefit part. For the incremental cost part, that's still very straightforward. So we just use this cost of B minus cost of A. Of C. So that would be just 45,000, and we can get this value that's 0.87, which is less than 1. So we will conclude. So we want to conclude with we will drop B. So C is better, keep C. Then our final conclusion will be selecting project C. So let me summarize the procedure doing like incremental benefit cost ratios of comparing multiple mutually exclusive projects. So the first we will reordering all these projects based on their cost based on their initial investment cost from the least costly to the most costly, like here, say CB, and then we will check first on the least costly project and calculate the benefit cost ratio. And if that's greater than 1, and we can keep as the baseline. If not, we move to the next least costly one, and check that benefit cost ratio until we found the one with the ratio greater than 1, and we set that as the baseline, and then we move to the second step. Second step, we use the next expensive one. Comparing with the baseline, calculating the incremental benefit cost ratio, and check if that's greater than 1. If that's greater than 1, then we can drop the previous baseline and set the new guy as the new baseline. If that's less than 1, and we will drop the current one and keep the original baseline. And then this procedure is repeated again and again to exhaust all the alternative projects. And that will be the general idea behind solving these kind of problems. So the complexity mostly will come from like adding more cost ingredients or benefit ingredients, and incorporating some of the complex structure we have seen in the previous like chapters or concepts. Okay. Do you have any questions? I think in homework there are some problems using a similar procedure to solve this. Hi, Matt, Victoria, do you have any questions?
I think I'm okay.
Okay, that's good. It's good to get a response. Okay, cool. Then another example of doing the benefit cost ratio, and that's a example of showing an unequal project life of years of project. So I will give you a 2 minutes or to just read through the. Let's get started on this problem on the left. So okay. So for this one, so it's still asking us to use the benefit cost method to determine from which of the following projects we should choose from. And for this question, so it's a little bit different from the procedure we have used used the previous problem, but in general that procedure should be correct, and you should be comfortable using that. But for simplicity here, because there are only 2 projects, and probably we don't need to compare, don't calculate the baseline. So here we just choose, since they're just 2 projects, we just choose the gravity field, gravity fed as the baseline. And then now we are gonna calculate the incremental cost benefit ratio. That's here. That's right. So the V, just call the project vacuum let as V and gravity fed as G. So from the chart, let me get some notations. So I want to draw so you can see that. Okay, it doesn't allow me to do anything there, but I think you can see my cursor. Okay, so as you can notice here, for these unequal life equal project life here. For this problem, we're going to just assume the repeatability here. So this project can be repeated for the gravity fed. So now then we can compare in 10-year horizon. So basically, for the benefit part, what we can observe is that 8,000 for both. So basically, if doing 10 years, we just use the 8,000 minus 8,000. That's just 0. So we kind of don't need to worry about that. Then, so what we want to compare as the benefit here. So instead, we can consider if we are, so so this for doing the gravity fed, we need another 5 years and do another capital investment using this 24,500 to at year 6, and so that can be regarded as a benefit if we choose the vacuum lab project. For this, do you have a question for this? So if we do vacuum lab, so that doesn't require things is 10 years life, so we don't need to have another investment. But for the gravity fab, we have to invest again. So that's actually, we save some money there for not doing the gravity fab for another 5 years. So this value, the 24,500, will be can be regarded as the benefit for doing the vacuum lab. So yeah, please let me know if you have any immediate questions. So because we don't have many people here, that'll be fine. Okay, so so the benefit part will just be the 2,4,500. This guy, but that's at the year So that's at year 5. That's like the 0 year of the 5th year. So let me draw a diagram. Year 5, 6, and 10. So the investment is always considered as at year 0. So for the project life from 6 to 10 years, and that investment is actually done here. So that's 5 years. So we want to do the present worth things, all the capital investment in the present worth value. So we do present worth. It will be more convenient in this problem. So that will be given the future value, since that's at year 5 of the investment, if counting that as a benefit if we do in the vacuum lab project. So and then we want to calculate the present worth, and we have this interest rate 15%, and that's 5 years, and that's just the incremental benefit if we're doing project B. Now the incremental cost part will just be straightforward. That's just the initial difference of the initial investment. So that's 37,900 minus 24,500, and this guy will be this value 12181. That's 13400. Definitely the numerator is less than the denominator, and that's obviously less than 1. So so we have a incremental benefit cost ratio less than 1, which means the project B, the V project vacuum, that need to be dropped.
Can you explain again why the second investment of the 24,500 is a positive change in benefit on the numerator?
Okay, yes. So if you consider you choose to do the vacuum because we are using the project V to compare with project G, right? So if we are using project V, then that means throughout the 10-year, we don't need to spend another $24,500 in that. So because that's spent by the project G. So the project G has an extra investment on the second part of the like the from year 6 to year 10. That's second investment.
Okay, and then why would you not kind of multiply the $8,000 annual receipts less expenses and include some form of the $16,000 since your life is being multiplied by 2 and you consider that second capital investment? So why do you neglect, I guess, doubling the annual receipts and expenses?
So if we do this 10 years, then I think the annual benefit for both projects will always be $8,000. So that will be equal to 0, the difference. So we can, for simplicity, we can just ignore that.
Okay, because it's every year.
Yeah.
Okay, thank you.
No problem. Yeah, that's good. That's a very good response. So yeah, let me know if you have any questions. Yeah, just let me write down this conclusion. Select gravity. Okay. I then we conclude this problem and we can move to the next. So do you have any other questions for other students? Okay, then let me go to the next one. So I think we have covered the first part. So the first part of the session is on the benefit cost ratio analysis. I think those 2 problems may be enough, but if you have other questions, we can answer after these problems. Or you can just let me know now and what kind of other confusions you may have. And then we will go to the other problems that's on comparing multiple mutually exclusive projects using other methods like present worth, internal rate of return. Okay. Just give you several seconds to reflect. Oh, you're feeling it's good to go, and I can just go ahead. Okay, so maybe I think we are good. And let's go to this question. This is a little bit long. So let me just make a title here. You can spend a few minutes, just read through this problem, get some familiarity. So you'll have a better understanding on how we formulate this problem. Let me continue. So this is still comparing 2 projects on equal lifetime, and we are asked to use 3 different methods. We first start from using the present worth method to compare these 2 projects, and let's get started. So the first guy, we want to calculate this present worth of project A. So what we have project A, and I think maybe it's let's draw the cash flow diagram for this guy. And starting year 0, I think there are some major time stamps. Those are 06, maybe 7 to 9. So for the year 0, the cap is the capital investment. So the capital investment for A is 222,000, and the annual receipts less expenses. That's the so that's here. Let's treat it as the cost part. So the annual ones will be maybe there are 2 ticks. So yeah. Just try to save the time to writing those ticks, but that's fine. So those are the annual expenses throughout 9 years since we're reading. Even though there is a lifetime for A is like 6 years, definitely we'll have these 6 years annual equal arrow here. And also we notice in this sentence, so on the basis of previous experience, the estimated annual leasing cost at that time will be 66,000 per year. So that's after year 6. So, but it mentions plus the annual expenses of 28,800 per year. So that's actually throughout the 9 years. So these small arrows will be also will have 28,800. And at the year 6, we have this market value for A that would be 25,000. Okay, then we also
I have a quick question.
Yes.
For the annual receipts less expenses being 28,800. Since it's the receipts that you're bringing in minus the expenses, why is it a downward facing arrow as opposed to being upward facing, since that's your like profit, I guess, would be the 28,800?
Yeah, that's a good point. So actually, you can correct me on this concept. I'm not too familiar with this concept. So the receipts is always annual. There's a revenue.
I think so. Like money you receive.
Okay, so if that's so, then it's just better to. Yeah, that's a good point. Anyhow, yeah, let me just reuse this. Yeah, since that's the benefit part.
And then it seems with the leasing being 66,000 per year after the 6 years, I think that would be like the 28,800 subtracted from 66,000 as opposed to being plus. Is that correct?
So for that one, that's separate amount. I think that's a separate amount from the 66,000. That's not added inside. So that's the extra one. So I kind of think that maybe this problem. I think maybe there's a typo there. It should be just expenses. Yeah, let's just say that's expenses. Yeah, I think that's the right way to go for this problem. Yeah, just treat it as annual expenses. Would that sound good to make it clear?
Yeah, so then the arrows were correct the first way you drew
them. Yeah.
Okay, sounds good.
Okay, cool. Just keep consistency in the wordings. Yeah. Okay. So yeah, just notice here, we're going to use the annual expenses as for both projects. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that was the 6. Okay. And we will have these expenses for all the 9 years. That's all. For A, that's all 28,800, and market value we have is 25,000 at year 6. So for calculating the present worth, another part, sorry. So another part will be starting at year 6. We will have annual leasing costs and another part cost. So that's the starting. Another, I think that's for 3 years, starting from year 7, 8, and 9. So that's for this 6,000. Okay, so we have these parts, and we all these arrows, and we all want to get the present worth. So find some value at year 0. Convert all the arrows to year 0. So we do this one by one. Now, first one will be the cost, the initial capital investment. That's just minus 272,000. And the annual expenses, that's minus. So that's the annuity. So we have the annuity of 28,800. So we want to find the present worth given the annuity 15% and 9 years. And the next will be this market value, and that's the that's inflow. So plus we have the market value of 25,000. And we want to calculate present worth given that future value. And since that's the year 6 to 0, that will be 6 years. And the last part, so the annual expenses, another annual leasing cost for years from year 7 to 9. So that needs a little bit extra work. So first, since that's annuity, we first calculate the annuity of the 66,000. Find the present worth, but this present worth is not at year 0. This is 3-year annuity. It's not at the year 0, but instead, these guys will be converted to this at year 6 first from using this factor. And we need another step to further convert this arrow back to year 0, and that's straightforward. We just need to find the present worth given the future value, since that's year 6 now, and 15%, and for 6 years. Maybe that's clear. Okay, so we have all the ingredients here, and then we do some calculation here, and we can find this values minus for 63758, and that's the present worth for project A. Okay, do you have any other questions? Okay, I think we are good. And for present worth of project B, that's actually more straightforward, since that's lasting all 9 years. and that's we don't need to do a lot transformation, just some standard ones. So we have the first, the capital investment as 346,000. Don't need to do anything there. And annuity is as a cost is 19,300 for 9 years. So calculate the present worth given annuity 15%, 9 years. And that's this part. And the market value of this project would be 40,000. And find the present worth given that's the future value. And it's at year 9, so 9 years. And we are done. And this value would be minus 426,720. Then just do direct comparison between the present worth of A and the present worth of B. And we'll find this value is greater than minus 463,758. So project B is better. So we select project B. And that is how we use the present worth method to solve this problem. And do you have any questions? Okay, let me know if you have any questions. And then the next one is we want to use the IRR method. Can you recall what is IRR method? I know it has been a while since we passed the midterm, but I think it's a good place here to just recall what we have learned. I think a little bit different is in the previous lectures or homeworks, we didn't use IRR to compare two projects. So, and this time we are going to use this method to compare the two projects. And just for a recap, so conceptually or graphically, what is IRR doing is we want to, so I think we have this the notation there in our textbook that it's all the net expenses and the net revenues, and set those to equal, or you put them together, or this guy minus this guy equals 0. And here then we want to find what's the interest rate, let them equal, and then check if that interest rate is greater than or equal to the given interest rate, and we can make a decision. So that is just what has been shown in this graph on the left. So that's basically we add up all the net expenses and the net revenues, and then set that equal to 0, and we want to find that interest rate that gets this present worth to 0, and use that to compare with the given interest rate. So do you have questions on this concept?
So you always have to use the present worth when you're doing an IRR comparison, is that correct? When you're comparing like the expenses and the revenues?
Yes, I think so.
Okay.
Yeah, but so okay. But basically, I think doing present worth is easier. given the formulation, I think in the textbook, that's always used in present worth. So I think it's valid to use present worth and to play safe.
Okay.
Yeah.
Mm-hmm.
Okay, so let's continue. And please notice this part. I don't remember if we have been talked about comparing, like using incremental, like comparing different projects using IRR. But I want just to give you this piece of information. If you have your textbook with you, and you can find, I think that's on page textbook page 257. There is this content like explaining using this method to solve this kind of problem in greater detail. So if you feel this is not enough, and you can read a bit more on the textbook, that's a good reference. And there's a nice chart. Let me see if I had that here. Yeah, probably. Yes, that's the one. Maybe let me do. So this is a more detailed procedure in the textbook, and describing how we use these the IRR, or present worth, future worth, annual worth method to compare different projects. So general idea, we always first want to rearrange or rank ordering all the projects by using ascending order of the capital investment, and then we select the least costly one as the base, and compare with the rest one by one. And based on the method we want to use, and we choose a corresponding method and calculate that either IRR or present worth or future worth, and then determine whether we should choose which project. And that's the general big picture. And then let me jump back. So now I'm just using this problem to explain how we're gonna do this method. So first, as we can see, we have the capital investment for A is 272,000, and that's less than the B's, which is 346,000. So we set A as the baseline, or a base. So we're gonna rearrange. So we can put rearrange a bit. That's easier for showing the calculations in all these steps. So project B compare with project A. Okay, and we want to get the incremental cash flow between the B and A. Not here. I just put the this is cash flow. Since for IRR method, we're going to use the net expense or net revenue. So it's good to. So I don't draw the cash flow diagram here, and instead I'm going to use this table to show year by year if that's not an annuity. So what we have for the year 0 on the B, the cash flow on the B will be the cost, the initial investment, that's minus 346,000. And for the A, that's the minus 272,000. And we take that, subtract that from B, and we will get minus 74,000. That's at year 0. We have this net cash flow. And from year 1 to year 5, from year 1 to year 5, we notice that's just annuity of A and annuity of B, and they're all expenses. So we have these 2 parts. So for B, that's for each year. So for for each year in the year 1 to year 5, the net cash flow will be the annuity of B. That's minus 19,300, and for A, that's minus 28,800. And we so that's, I think Victoria has left. I didn't have a chance to say thank you, but okay. And then that's 99,500. And we don't, we separate the year 6 because project A will end here. We'll have the market value. So we just have a different part. So for B, it's still minus 19,300. But for A, that will be the annuity at the 6th year. That's 28,800. And the market value. So this market value would be to 25,000. And we have this minus. That's the net cash flow for year 6. And that would be minus 15,500.
I have a question about adding. Wouldn't you want to add the 25,000 as opposed to subtracting it, since it's money that you get back?
So that's a good point. So this one, that's expenses, right? That's the minus sign, and this is the market value. So that's actually the money you can get once A is ended. So that's an inflow. Cash inflow.
Oh, is that a positive sign that you drew in between those?
Oh yes, that's a positive sign. Sorry.
Okay.
I think that's I should write that more clear. That's a good point. Yeah, writing is also important. No problem. That's a good point. Okay, and so we are good on that. And for year 7, 8, since that's just the annual expenses for both, and then we will have still for B, that's minus 90,300, and for A, right, that's minus. So this one here, we have minus 66 for that one, and and don't forget we still have this 28,800 together, and we calculate the difference between these two, and that will be 75,500. Okay, and then at the year 9, same idea. From at project B, we still have the annual expenses. That's 300, but this time we will have the market value for B, and that will be plus 40,000. And for A, that's the same thing happening in year 7A. So we are just subtracting this guy together. And we will have 115,500. Okay, so now we have ready on these net cash flows for each year, and then we're good to go. So So here I'm just gonna, so for using the IRR, we are calculating this interest rate. And when that it gets to 0, so we just use this graph, but you can also write all the all this net cash flow, so all the net expenses plus minus the net return, the revenues, and set that equal to 0. So that's the abstract form. Now we just plug in what we have for each year. So we're starting from year 0, and that's just minus 74,000. Now from year 1 to 5, that's 9,500. So we calculate the present worth given annuity. And this guy, we don't know. And that's 5 years. 5, that's 5 years. Okay, and then move to year 6. That's nothing mysterious, just minus 15,500. And given the future, we find the present worth. Unknown guy. That's year 6. Now we proceed to year 7 and 8. And that's the same trick we will use. It's not a trick, actually, just be cautious. Is we first we first transform the annuity from year 7 and 8 to the present worth in year 6. So we need further roll back that value to the year 0. So we need to apply 2 factors. So we have this annuity 75,500. So that's the annuity we have. We need to find the present worth at year 6. Then we don't know this guy. Yeah, that's 7A. That's 2 years. Since this present worth is at year 6, so we need to further apply another factor calculating the present worth at year 0, given the future value. That's the cash flow on year 6. So don't know this guy, and roll back to the year 6. Okay, then the last guy will be on the year 9, and that's straightforward. This guy we need to calculate present worth given that's future worth, interest rate unknown, and 9 years. So this is long, and I think there are 2 ways to do this problem. The first one, I think, an easier one, and a labor-intensive one. So the easier one would be you can use a computer. So first, you can explicitly write these factors with the unknown I. So write out the mathematical formulation. The second step is you can just use the computer to solve that equation. Since some of these guys will include some 1 plus I % to the power of some year, and can become very complicated if you're doing that by hand. So instead you can just use a computer to do this. Or the second way is you can use the table, use the appendix, the table in the appendix, and find out those like corresponding values for these factors, and plug it in and find which one let this equation get closer to 0. And maybe you can find the one a little bit larger than 0 and a little bit less than 0, and you can do the linear interpolation. But the point I want to make is here we don't really focus on how you really get this number, so I don't really jump into the calculation part. And I also don't think in your future tasks will be asked to do complicated computations like this in a written exam, so don't need to worry about that. Then let me just get this I value for you, and that will be 22.5%. And we are given the interest rate that's just 15, right? Yeah, I think that's 15 here. So that's greater than the 15 interest rate. So as we have known from the IRR method in this chart, so as when this IRR is larger than or equal to this given interest rate, and we can conclude the 1. So since we set A as a baseline and we use B to compare, and we get this interest rate is greater than the given interest rate. The IRR is greater than the given interest rate, so we can conclude B is better, so we can select B. Okay, do you have any questions until this step? Yeah, give you some time to think a little bit. Just summarize what we have done for using the IRR method. So we need to first get to know the idea to get the IRR is to set the for all the years we need to get the net cash flow. So the net expenses, we put together all the net expenses and net revenues together, but we don't know because we want to calculate the interest rate, the internal rate of return. So that interest rate is unknown in the setup. And we set that equal to 0, and we get this interest rate. So for the first step, because we are doing the incremental analysis using the IRR, and we need to choose the baseline. The base will be the least expensive one in regard of the capital investment, and then we calculate the net cash flow for each year. And then we calculate the present worth of putting all the expenses and net revenues together. And we can get that internal return of rate and compare that with the given interest rate. And then we can get some value and make the decision. Okay, are you all good?
Yep.
Okay.
I'm ready to move on.
Cool. So now let's do the next problem. So the ERR one. Yeah. So just first let us do some recap on the ERR. So the ERR is a little bit more complex than the IRR, but by using this graph on the left, I think it makes us easier to understand what's going on there and what we want to get. So basically, the same thing is we still want to get the net cash flows for each year first, and then we what we do is, let's see, I think it's easier to do this way. Okay, that's nice. So I can draw something here. So then we can have, since we have all the net cash flows for each year, then we will separate the net expenses and net revenues, and then we will transfer or convert all the net expenses. Somehow this is okay. It's not working. That's weird. Somehow this app is OneNote. That's weird. I cannot change my pen, but okay, I think you can still see the cursor at least, maybe. So we first convert all the net expenses to the present value. This is the net expenses, and then we put all the net revenues, net inflow in cash flows to the future, and then we want to know what is the interest rate or external rate of return that will bring this expenses, all these net expenses at the present, to the future, and so that the two will equal. So basically, and this guy is given, and that's usually the ARR in the problem. So what we want to know is, so we first get all the net expenses. This means we get all the outflow, the expenses, converted to the present value. It's this part. And on the net revenue part will be, we bring out all the net revenues to the future. And then we want to find so we want to first convert this guy to the future, given the present worth, and find the future value, and we want to find this external rate of return, and so these two parts will equal. So the most important thing is we always want to get the net cash flow for each year first here. And let me see if I can do this one. So we don't have to, since we will have the same cash flow, our cash flow chart, then we don't need to do this again. So what I want to do is I will copy this bill down and so we can save some time not to write this again for each year. So we're gonna still use this information, but the different procedure we're studying from now. So that would be, let me bring up the problem. Okay, so we want to get is the net expenses part. Since we we are putting them together. So we're gonna treat the cost now as a positive value, because we are compare the absolute value of these two. Then on the cost part, that will be 74,000 minus 74,000. And the other expenses is at the year 6, and we put that together. That's 15,500. We have, well, we given the future value, calculate the present worth. That's 15%, and for 6 years. And then we will take this, because then we are done for all the net expenses, and then we want to further take this to the future. So we have the future, we want to calculate the future value given the present worth, and we want to know this external rate of return, this interest rate. And so since we're going to bring that to the future, it's at year 9, so we put in it's 9 years, and we have the left hand side. So this one will be just this part. Now let's do the right hand side part. So all the net revenues here. So we're starting like these guys. So first one will be from year 1 to year 5, and that's 9,500, and we want to bring that to all these guys to the future at the year 9. So first, it's the same thing. So because we're getting the annuity, so then we calculate the future value. So so we given annuity, that's 9,500. Calculate the future given A, and that's 15%, and that's 5 years. 1, 2, 3, 4, 5. Yes, but remember that's at year 5. That's at year 5. But we want the future value at year 9, so we want further take this forward to the year 9. So we given the present value to find the future value, and still 15%. And there's another 4 years. So this guy will have the future worth at year 9. Okay, so now we have for the next piece, that's 75,500, and that's the same thing. So we need to calculate the future worth given annuity 7A, that's 2 years, and bring that forward. So that's at year 8, and we bring to the year 9, so 50%, extra 1 year. And the last piece, will be just the guy here, since that's already at year 9. And actually, it's easier to calculate this guy, since we sorry, it's not this guy, it's this guy. Since we only have a complex structure for this factor, all the others are known. So what we will have is on the left, that's 8,701 times That's 1 plus I to the power of 9th, and that equals, the right hand side will become this number, and this one can be calculated by the calculator very easily, and we can get the ERR is about 19.9%, still greater than the 50% of the interest given. And then we will conclude that still B is better. So select B. And let me just revisit what we have done here. So we first still have all the net cash flows for each year. And then we just use this formulation given in the ERR method. So we put all the expenses to the present and put all the future, all the net revenues to the future, and with the extra factor we need to calculate, which brings the present net expenses to the future, and calculate what is that interest rate. And that's the idea behind it. And I think we are done for the ERR method. Okay, do you have any questions? Yeah, it may take some time to think about it.
I don't have any questions.
Cool. Okay. And let's do the last one. So last one will be fairly straightforward, since now it's changing the scenario of for A. So if we will lease the crane A for 9 years and assume the same cost per year for 3 years, which would be preferred based compared to B. So so we are gonna use the information we already got from the problem A. So the present worth for A and B we already have here, and so we want to just use the present worth method to do this problem, so that we can make comparisons fairly easy. And then so the present worth of the current new project will be, since that's just a leasing, so we only have the annual expenses. That's 6,000 plus the 28,800, and that's the annuity. So we have the present worth given the 15% in 9 years, which will be minus 452,348. Yeah, so because it's just leasing, so we don't need to account for the capital investment for the ape. So this will be the present worth of this leasing project, but that's minus 4,523,48, which is greater than the B. So the B will be minus 426,720, but still less than the A, the original A, which is minus 463,758. So the project A prime will be, the leasing project will be better than A, but not better than B. So if we consider from all these three projects, we will still select B. But that's a direct conclusion for that, but that's the final conclusion. Okay. Do you have any questions here? Yeah. Please feel free to ask if any part is you're feeling confused. That'll be fine.
No, I think this makes sense.
Okay, cool. It's good to know, and thank you for your response. And so we still have about like 14 to 15 minutes left. So there could be two options. Option one, you can ask your own questions for the rest of time, and I can help you, or I can show one more example, and we can go over that again. I'll go over that problem. What would you prefer?
Could you do another example problem like the one that you did about the gravity fed and the vacuum fed projects? I'm not sure I fully understood that one.
Okay. But I think this so this problem is kind of special, looking special. So I picked this one, but unfortunately, I didn't find more examples like in this kind. For the others, they're more. I think they are more clear. So the problem setting is not like here. You have the same annual expenses, annual receipts, so you don't really to calculate that, but instead you consider the difference of not investing in another, not for another 5 years for the baseline project. So maybe I think it's good to just review this problem again, because I don't have similar problems prepared for now on this particular setting. So I think for this problem, because I haven't done that way, but you can try and check. I think the solution, or not the solution, the conclusion should be the same. So you can still try try to calculate the benefit for each and the cost for each, and calculate the incremental benefit and cost. But the thing is, the bad thing is, if you do it that way, if you still consider this extra investment as another cost saved, then you will get the numerator as 0, and there's no way to compare because the ratio will be just 0. And I will say why we still want to count that as the benefit. It's just like I don't know, it's just a very natural way to feel like if you have to invest this twice, but you only invest like the project V as once, you can treat as if I don't invest that again, I save that much money. So that can be treated as extra benefit if I'm using the vacuum project to compare with a gravity project?
I think that makes sense, but I'm like wondering why on the numerator you wouldn't have to do like 37,900 minus the present value of that second investment, or some like combination of looking at the difference in the total investment then over the 10 years for the gravity fed as opposed to the vacuum led, and then if you see that benefit. I guess in my mind it's kind of confusing why if you invest 24,000 two times, that's going to be greater than 37,000 in the long run. So maybe like a cash flow diagram of kind of what that looks like when you double the life of the gravity fed might be helpful.
Yes, let's do this. Okay, so the capital investment for the gravity 245, and for this vacuum, so it's 37,900, and for since that's 5 year for the gravity 5 years. So we need to have another investment as 2, 4. And we have all the equal annual income. So since we are comparing both, right? And then we need to use and the capital investment for the G is lower, so we can treat that as the base and use this guy to minus that, right? And then all these 8,000 guys will disappear, since they're just equal. But for doing the project V, right? This V at the year 5, that's actually a zero cost. So 0 minus this guy, the cost of doing another investment for project G, and 0 minus this negative guy will resulted in the positive. I think this way can explain this problem much better. That's right.
Yeah, that makes more sense.
So that will turn to the positive value, and that should be put as the numerator. Yeah. But thank you for asking for clarification. I think it does help me and help you. That's good. Okay, and we still have 8 minutes. So let's see. So another example I can do is this guy, and let's see if you want to talk about this problem, or you have other questions. I can help answer. Okay, cool. Okay, let's just get started. So okay, it's asking us to compare 2 different projects, and we can start with the first question here. So we have this assumption, so assume the equipment will be needed indefinitely, and given we have the unequal life years for A and B, A is 5 years, B is 10 years. So given that is equivalent to the repeatability assumption, so we will have this. So we can actually use the annual worth method to do this kind of problem. So now what I want to get is the annual worth of A and the annual worth of B. So we started with A. So what we have. So first at the year 0, we have the capital investment for A. That's minus 20,000. And we have this as a present value, but we want to find the annuity given as 20%, since life years is 5 years, and we want to find that's the annuity for 5 years. So that's for capital investment, and the annual expenses. I think just change it as the annual expenses. So the annual expenses would be minus 5,500. That's already in annual value, so we don't need to do anything there. And then the last piece was the market value. So the market value is positive, and we want to convert that to the annual worth. So because the market value is at the year 5 for A, end of life, so we are given the future value of finding the annuity, and 20%, 5 years, and then we will have minus 12,000 and 53.6. That's for the annual worth of A. And now we want to have, just for clear notation, let me add this repeatability. Repeatability assumption. Okay, so now we calculate annual worth of B, and that's just the same thing, but it's for 10 years. So for the first capital investment, convert to the annual annuity. So given the present worth, 20%, that's for 10 years, and the annual expenses 4,000, and then the market value 4,200. And we want to calculate the annuity given that's the future value at the end of year 10. So we have this one, and we have all the ingredients. This guy will become minus 12,901.3. Okay, so we have this one as less, so actually the cost of B, annual worth cost B, is larger, is actually larger than annual worth of cost A. Then we conclude by selecting A, and that's for the first problem. Do you have any questions there?
No, that makes sense.
Okay, cool. So, okay. Now let's get to problem 2. So assume that study period is shortened to 5 years. The market value of the alternative B after 5 years is estimated to be 15,000. And based on that, what should we choose? So this is a scenario when we have the study period is less than the useful life. In this case, that's for B, since B have 10 years study period is 5 years. So as said I think in the class as well as in the textbook, when we encounter the scenario for projects which has longer useful life, we may want to get the market. So it's actually the market value. It's not a scrap. I think it's not a salvage value, but really the market value after at the study end of the study period. So we need to know the market value of B at year 5 in this case. And for this problem, we are given this information here, but it's possible that, but I don't think we are gonna do this complex thing. But just let you know, if you don't have this 15,000 in this problem, what you can do is, so we have introduced the technique, like you can use the DB ratio, DB method, like those, to get the market value of some project before their end of their useful life. But here it's much simpler, and so for A, we already got, we don't need to do anything because its life year is already 5 years. Study period, it matches with the study period. You can just copy that value down here. That's this guy. And we just need to do some manipulation on the annual worth of B. So now we've taken that as the 5-year project. So we will have is first the investment at year 0, present. So convert that to the annuity and give them the present 20%. Sorry, that's 20%. And for 5 years. And annual expenses still the same. 4,000, and now we just update the market value information and use a new market value given in problem in the question 2. So that would be 15,000, and convert that to the annual worth. So find annuity given the future worth at year 5, 20%. Year 5, and we got that number minus 14. 691.2. Yeah, it's already larger in terms of the cost. The cost of B now is larger than cost of A. And we still conclude select doing project A. Then we are done here. So the just summarize. So for this problem, for first part with unequal life and with the repeatability assumption, we can use annual worth method. That's a very perfect match for this kind of problem setup, and we can compare the annual worth of different projects and to select which is better. And for the second problem, the point will be if that useful life of some project is less or is greater than the study period. So that means the project will end earlier. So then we need to get to know at the end of the study period what is the market value of that project with the longer useful life. And again, we are recalculate the annual worth of that project with a longer useful life, and calculate that annual worth based on the current study period. And we compare the annual worth of these projects and make the selection. Okay, do you have any questions for this problem?
No questions here. Thank you for doing this.
Okay, no problem. Thank you very much for attending.